All right, my students, here are the answers for the Chapter 19 review questions. Number one says, what's the difference between the troposphere and the stratosphere? And what key role does the stratosphere play in maintaining life on Earth? So let's head over to the notes that I posted. And so if we take a look at the atmosphere, right? Of course, we have the planet and all the gases that extend up above the planet, off the ground, right, make up the atmosphere. And the atmosphere can be broken down into different sections, right? The bottom part that's closest to us, where we live, where all life exists and where all weather occurs, that's the troposphere. All right. Above that, we have the stratosphere. Above that, we have the mesosphere, and above that, we have the thermosphere. For this class, you really just kind of need to focus on these two, and really remember that the troposphere, right, as I said, this is where we live, right? This is the layer of the atmosphere that's closest to the Earth. All life exists here, and where weather occurs. And as we move up into the stratosphere, we have to remember that gravity is actually holding all these molecules right to the Earth, and so it's there's more pressure when we're sort of at the bottom of this atmospheric pool, so to speak, right? Kind of like if you ever go into a pool and you swim down deeper and you feel that pressure in your ears. Well, it's really all the weight of the water pressing down above you. Well, this really what's happening in our atmosphere as well. We're just kind of used to it down here. But anyway, so above the troposphere, right, is the stratosphere. So there's less oxygen up there and everything. But the one very important thing to remember about the stratosphere is that is where the ozone layer is, right? And ozone is an O3 molecule. And its very important job is it absorbs a lot of the sun's harmful ultraviolet rays, or UV rays. These rays are powerful enough to not only like burn skin, but also cause cataracts, like of the eyes. So it's hard on the eyes. Not only ours, but of course, other animals and other species as well. All right. So it's very important that in our ozone, we have a very healthy ozone layer to filter out those harmful UV rays. All right. Number two, what is the difference between a primary and a secondary pollutant? Well, like you can probably determine, primary comes first and secondary comes after that. So let's take a look at this graphic right here. So primary pollutants, you can kind of see them here, and secondary pollutants over here. So how this works is, first, a primary pollutant is produced, right? I don't care if it's carbon monoxide, carbon dioxide, sulfur dioxide, right? Nitrogen oxide. Sometimes people call them NOx and SOx. NO, sort of with an X, meaning because it can be NO or NO2. So nitrogen oxides, so nitrogen with oxygen, or SOx, sulfur oxides. So in other words, these are produced first. Then once they are released, then those things react with things in the atmosphere and produce the secondary pollutants, okay? Sulfuric acid, nitric acid, things like that. So in other words, if you want to stop the secondary pollutant, you got to stop producing the primary pollutant. All right. All right, question 3. Explain how nitrogen in the air, which is N2, can be converted into nitric acid. So it's very important to remember that the two main things in the air that we're breathing right now, 78% of the air you're breathing is N2 gas. So, right, nitrogen, N2. 21% is oxygen, O2. So 99% of what you're breathing right now, nitrogen and oxygen. All right. Now notice, they don't want to react. In other words, if they were just in the atmosphere, they're bumping into each other, nothing happens. Okay, they don't want to react. But you maybe remember from your chemistry day, if we add energy, enough energy, sometimes we can get molecules that don't want to react. We can actually get them to join together. So that's sort of a hint with number 3. How does the nitrogen actually convert into nitric acid? Well, we got to add heat, a lot of heat. And so let me share this graphic with you here. So nitrogen oxide forms when nitrogen and oxygen that are already in the air, right, react at the high combustion temperatures in automobile engines and coal burning plants. Also, by the way, lightning has enough energy to make these nitrogen and oxygen to join together, right? And some bacteria can do it also. But in other words, imagine this. So in a car engine, right, there's atmospheric air that needs to be fed into the engine, right? So there's nitrogen and oxygen. Normally they don't join together, but in the internal combustion engine, so in other words, we have some fuel being injected in and we have a spark which creates an explosion, right? That pushes the pistons up and down. And so we have this controlled explosions of spark plug igniting the fuel, right? And that drives the wheels. Well, remember, as these explosions are going on, it gets very hot inside the car. Now, at those temperatures, hot enough, the nitrogen and oxygen that naturally exist, right, that occur in the air, now they join together. And that starts this process, right? So now they join together and they form nitrogen oxide, NO, right? And then that goes out essentially, right, the exhaust. So in other words, if you follow down here, so first we start with the nitrogen oxide, the NO. And remember, that formed just because of the heat of the engine. If you didn't have that heat of the engine, the nitrogen and oxygen would not go together. So I want to make that point. So anyway, so again, the high temperature heat of the engine makes these two join together and forms the nitrogen oxide. Then of course, as it's leaving, there's air, oxygen in the air, right? That then forms nitrogen dioxide. The nitrogen dioxide, right, then reacts with water vapor, humidity, rainfall, all that kind of stuff, right, to form nitric acid. There you go. So in other words, you know, it starts with the combustion heat. Also, coal burning power plants, right, where you have all that heat. Frankly, anytime you're burning a lot of stuff, there's enough heat energy to get some of this forming. All right, and the more we burn, the more this that we're going to produce, which then, and then you're going to have more nitric acid or acid deposition, right? Acid rain. All right, so the burning of anything, fossil fuels, and we burn a lot of stuff, right? Gasoline, coal, you know, natural gas, all those kind of things. Anytime we're burning stuff, we're going to have some of this. We're going to start this process, right, of the nitrogen oxide, nitrogen dioxide, that then reacting with water in the atmosphere to make nitric acid. So in other words, we want to stop producing so much or causing so much acid rain, we need to stop burning so much stuff. Okay, question 4, explain how the sulfur in coal can eventually be turned into sulfuric acid. So I want to first start off with reminding you that coal is the remains of plants that lived millions of years ago. All living things, right, have sulfur in them. It's a critical component of certain amino acids. And so, you know, of course, the plants had sulfur in them at the time. And so, of course, there is some sulfur in coal. So I want you to imagine now that sulfur is, where was it? Is buried underground, really never supposed to come out again, except we have figured out, boy, there's a lot of energy, stored energy in the coal. So we bring it up to the surface and we burn it. And then when we burn it, the sulfur that was in there, let me share this graphic with you here. So let's jump to here. But real quickly, so the sulfur in the atmosphere, right? Then like nitrogen, as it's burning, reacts with oxygen, which makes sulfur dioxide. Sulfur dioxide then reacts with water vapor to make sulfuric acid. So here we go. About 1/3 of the sulfur dioxide in the troposphere, remember that's that lower layer of the atmosphere that we live in, occurs naturally through the sulfur cycle, okay? But 2/3 come from human sources, also known as the big word, which you might see on the AP exam, anthropogenic sources, right? Anthropogenic simply means human. All right, let's just say that, right? But anyway, anthropogenic, 2/3 come from human sources, right? Burning stuff, burning coal and other things, right? So remember, there's the reaction right there. The sulfur that was in the coal, when you burn it, it then reacts with the oxygen that's in the atmosphere to make sulfur dioxide, right? That's the primary pollutant. And then that sulfur dioxide goes into the air and it reacts with the water that's in the atmosphere. And then it is converted into sulfuric acid. Okay, so again, burning stuff is associated with acid deposition or acid rain, acidic snow, that kind of stuff. And I don't care if it's burning coal or burning gasoline or whatever. Anytime you're burning stuff, you're going to put the nitrogen oxides in the air, and you're also going to be producing or releasing the sulfur dioxides into the air if you're burning things that have sulfur in them. All right, question 5, what is smog? Well, smog is a made-up word, right? We're all familiar with fog, right? Natural fog, if you look outside. Well, smog is something we created, and we made up this word, right? Because it looks like fog, but it's really kind of the emissions, the smoke. And so we kind of put this together, so it's smog. So smog is what looks like fog, but it's that haze, it's the stuff in the air that's really from the emissions from whatever we are burning, whatever we're releasing into the atmosphere. That would be smog. All right, 6, what is suspended particulate matter? And what concerns do we have from it? All right. So have you ever, I'm sure you probably have, been sitting down and you maybe see some light coming through a window, or maybe at a movie theater, remember those? And you look up and in the beam of light, you can see all this stuff floating, right? Guess what? Those are suspended particles, suspended particulate matter, right? Very light. Now, by the way, the big ones we can see. And we have a lot of defenses, right? Like in our nose, we have hair and we have mucus and all that kind of stuff that's designed to really kind of catch a lot of that stuff. All right. But if we overwhelm the system, right? If we are burning lots of stuff, putting lots of this suspended particular stuff in the air, you can keep in mind, if you look up and you saw that beam of light and all that stuff floating up there, why would it only be up there and not floating around here too, right? In other words, so it's, yeah, you're probably also breathing some of this stuff in as well. But again, as long as you don't overwhelm the system, we've got, things in place with the human body, like I said, the hair and the mucus to kind of get rid of it. But if we overwhelm it, right, we don't want to be breathing air that is overloaded with suspended particulate matter. It has a lot of stuff in the air from burning things and that kind of thing, right? And there are some particulate matter that's so small, right? This ultra fine stuff, it's something you can't even see it in the air, right? You breathe it in and that can easily get past our defenses deep down into our lungs and cause problems. All right, so 7, what are volatile organic compounds, or VOCs? So VOCs are these volatile reactive gases that are released into the atmosphere, okay? And they're reactive, and you want to limit your exposure to them, obviously, if you can. Right, and we can see from the notes here, right, the VOCs are hydrocarbons, compounds that have hydrogen and carbon in them, can be released by the leaves of many plants, and methane. About 2/3, though, of global methane emissions, right, come from anthropogenic sources or human sources, and other VOCs are solvents, right, that we produce. Another place you might see this, by the way, for example, let's say you're painting. If you're ever going to paint a room, it always says make sure it's well ventilated. Why? Because you're breathing this in and potentially the volatile organic compounds. You can look for paints now because people are asking for them, like it shows here, low or no VOCs, no volatile organic compounds. And because again, it's just the idea that not only are those gases being released while you're painting, but frankly, even as it dries, it can still be off-gassing these gases for quite a while. And a lot of people don't like the idea of breathing those in. All right, question number 8. What is radon? Where does it come from? And why should people be concerned about it? Now, if I were to ask you, what is the #1 cause of lung cancer? And if you think it's radon, you're wrong, actually, right? It's smoking cigarettes. But guess what the #2 cause is? And that's radon, right? And here's the deal with radon. You can't smell it, you can't taste it. And so you could be breathing this in and don't even know it. So what is it? Well, here we go. Let me share this with you. So radon 222 is a radioactive gas from the breakdown of uranium found in some soils and rocks. And guess what? Here in Michigan, in our area, it's very common to have this in our soil, okay? And so our homes are built above it, right? As you are on the soil, as you can imagine. When this gas forms, it can make its way up through the cracks in the floor, and it kind of hangs out, generally speaking, on this lower level, okay? So this radon, again, it's a radioactive gas. It is the second leading cause of lung cancer. So you want to know if you have radon gas in your basement or lower level. So here's the deal, right? I mean, especially if you or someone lives in the lower level, lives in the basement. If you have a finished basement, you spend a significant amount of time. Frankly, even if you go down there just from time to time, I mean, like you should know what your radon levels are, but especially if you're spending any sort of time in your basement, right? And by the way, you can go to Home Depot, Lowe's, pick up a radon test. They're very inexpensive, and it's very simple. You basically go to your basement, you follow the directions, right? But generally speaking, for most of them, you just take the top off and you leave it for 48 hours. After 48 hours, you put the top back on it. There's a medium in there that the air will just naturally settle on. Anyway, you put the top on it, you send it back to the company in the envelope that they gave you. And in a couple of weeks, you'll get the report back on your radon levels. And hopefully, it'll come in acceptable and you go on with your life. Now, if it's high, no worries. They have easy remediation systems. There are companies out there. Generally, I don't need to talk about. Generally, they put when you want to pump some of this air out, right? So they put a little PVC with a fan that basically pumps it outside. It's very simple to remediate, and you can take your risk of radon almost down to nothing with these radon remediation systems. So you want to know, and just because your neighbor next door doesn't have radon doesn't mean that you don't. Okay, so again, highly recommend knowing what your radon levels are. And like I said, you can go to Home Depot or Lowe's and get a radon test. Very inexpensive and know in about 2 weeks. Second leading cause of lung cancer, and you can't smell it or taste it. All right, number 9 says, what is industrial or gray air smog? And how does it form, and what areas are most affected by gray air smog? So notice number 10 says, what is photochemical smog? So we're talking about 2 different types of smog. So 9, industrial or gray air smog. Guess the color of gray air smog. Gray, right? Which is different from 10, photochemical, which is a brown. But all right, so let's stick with 9, the industrial gray air smog, and what areas are most commonly affected by it. And here we go. So industrial smog, also known as gray air smog, is a mixture of sulfur dioxide, sulfuric acid, suspended particulate matter, emitted mostly by burning coal. All right, burning coal and heavy oil, stuff like that. Those are the places that are going to be most affected. So coal burning areas will be more likely to have gray air smog, and of course sulfuric acid and acid rain caused from the burning of the coal and the heavy oil. All right, question 10 says, what is photochemical smog and how does it form, and what areas are most affected by photochemical? So now whenever you hear the word photo, like photosynthesis, there's a clue there, right? Sunlight. So sunlight is involved with this. So let's go to here. All right, so photochemical, also known as brown air smog. And 1 second, let me make sure. There we go. All right. Essentially, it's associated with areas, hot climate, lots of sunlight, and cars burning stuff. All right, so watch this. So here is sort of the chemistry of this. Now remember, what makes up 99% of the air right now, right? Nitrogen and oxygen, but they don't want to join together, right? But with high temperatures, like internal combustion engine cars, coal burning power plants, that's enough to make them to join together and make nitric oxide. So let's follow this. So this is step number 1. Remember, it's like the domino effect. This, which then causes this, which then causes this. So we start this chain reaction, or this series of events, right? The dominoes falling. The first push is the burning. Internal combustion engine, coal burning power plants. But let's go with the internal combustion engine, right? All right, so then the heat of the engine makes a nitric oxide form. Let's run down here. Now we have nitrogen oxide. And of course, there's still oxygen in the atmosphere. Well, that then reacts together to make nitrogen dioxide, a brown gas, choking odor. There you go. All right. So if you want to cut down on your, photochemical smog, then you can, stop burning so much stuff like internal combustion engine car. All right, good. That's what that produces that. All right. Let's take this a step further, though. Right. The nitrogen dioxide. It then reacts with the water, again, to form nitric acid. So remember, acid rain. Let's now take this nitrogen dioxide. Remember talking about photochemical light? This is where this plays a part. Okay. So the nitrogen oxide, when it's produced, right, it can react with water to form nitric acid, or it could take this route too. The nitrogen dioxide on a sunny day, when the rays are intense, the rays will come down and it will clip off one of the oxygen molecules, right? It separates it, right? So then we're back to this nitric oxide plus a free oxygen. Now this is significant. This free oxygen is extremely reactive. It then joins with the nearest O2 and makes an O3 molecule. Now O3 is ozone. Now remember, maybe you said, wait a minute, I thought ozone's good. Well, it depends where the ozone is. Ozone's a very reactive gas. Up in the stratosphere, love it. Right. It absorbs the UV rays, it protects us, which is great. But at ground level, when this all happens, right, you burn the internal combustion engine, and the nitrogen dioxide goes out, the UV ray cleaves off one, you have a free oxygen, that free oxygen then joins with the O2 to make O3. When that's going on at ground level, not good. All right, you don't want to breathe ozone in, right? It's a very reactive gas. And so listen now, maybe you've heard of ozone action days, but now it'll make more sense to you when you finally do hear it. An ozone action day very likely is going to be a hot, very sunny day. And they're going to ask people, hey, listen, if you don't have to run your car, run your lawnmower, and so forth, between 10 and 2 or 10 and 3 or so, please don't. Because, and you might say, well, what does that have to do? Remember, sunlight is most intense during those times, right? 10 and 2, 10 and 3. And so if you're running your engine and your lawnmower, then all this happens, right? The nitrogen oxide forms, right? Sunlight clips off the oxygen, the O reacts with the O2 to make O3. Okay, so that is that. All right, question 11. What is the grasshopper effect? Now, an easy way to think about this is, what does a grasshopper do, right? It jumps and then it comes down, and it jumps and it comes down, whatever. So we have to remember that essentially when we release stuff to the atmosphere from burning, I don't care if it's a smokestack, I don't care if it's exhaust pipe of a car, whatever it is, well, often it can be carried up in the air and then it can fall to the ground. Miles and miles away, right? And so that's this grasshopper effect, meaning when pollutants that are being released to the atmosphere in one place, they may end up in a place far, far removed. And in some ways, you know, sort of the injustice of it all, that where this exhaust lands, those people can be affected in those areas, but yet they're not the source of the pollution, right? It's coming from another place. And so, you know, when we exhaust things into the air, I heard someone say one time, I thought this was pretty spot on, you know, I think most of us would be offended if we saw someone dumping some toxic waste into, let's say, a lake. Like that would seem obvious to us, like, wait, you can't do this. But yet, very often we can see things being, you know, released to the atmosphere almost as if it's just an open sewer, you know. Now businesses do have regulations that you know they have to meet as far as what's going into the atmosphere. But anyway, so that's the grasshopper effect. It goes up and then it comes down someplace else. It can come down on the land, and then as grazing animals eat it, right? It can get into them that way, or it could land in the water and pass through food chains that way, and bioaccumulate and biomagnify as it moves up the food chain. All right, question 12. What is a temperature inversion or a thermal inversion, and what are its harmful effects, and what types of places are most likely to suffer from prolonged thermal or temperature inversions? Now, to answer this, I first want to ask you this question. What makes if you heat up a balloon, a hot air balloon, right? What happens to it? It goes up. Hot air is less dense, so it goes up. And what happens to cold air? Cold air is more dense, so it goes down. So we'll start with that to help understand this. All right, so first, 1 second, make sure we got this here. So temperature inversion or thermal inversion, right? Cold, cloudy weather in a valley surrounded by mountains can trap air pollutants. I'll explain that in a second. Right? Areas with sunny climate, light winds, mountains on three sides, and ocean on the other side are susceptible to inversions. So let's take a look. I guess this one works here. Imagine this city right here. All right. And there are cars and there are other things going on, and you have all these emissions. Now, what do people want? Like the point of a smokestack and that kind of stuff is to kind of push that toxin up way into the air and get it away from people. So ideally, they would want all that stuff just to go away. All right. And notice that in this case, this is in a valley. So imagine that all these exhausts are going, and then a warm front moves in. Now remember, warm air is less dense than cold air, so it will float on top, right? So if in this valley area or around with the mountains, that warm air kind of slides over the top, it will prevent this cooler air from leaving. And so all this kind of stagnant, so to speak, air will just be in here. And so it is not a good day to go outside to breathe this in when you have these temperature inversions. And again, they're caused by a warm front kind of moving in and blocking that. Like we all know, you should not be in a garage with a car that's running because of the carbon monoxide and the fumes, right? Well, you know, if the garage door is closed, it can't escape. You know, if the garage door is open, then fresh air can come in. And it's the thermal inversions is similar. I mean, you have all this bad air here, and as the warm front slides over top, it's sort of like the garage door closing and trapping in a lot of those pollutants. All right, so again, that's a thermal inversion or a temperature inversion found in places like this that we talked about. You know, it's caused by that warm air sliding over top and sort of trapping it in. All right, question 13. What is acid deposition, and why is acid deposition a regional problem? And what areas in the US tend to be most affected by it? All right, so let's take a look at this. So acid deposition, right? First, it starts, generally speaking, with the burning of stuff, fossil fuels and that kind of stuff, right? So sulfur dioxides, burning from coal, nitrogen oxides from burning anything, right? In our internal combustion engines and at high temperatures, right? So sulfur dioxide, nitrogen oxides, particulates can react in the atmosphere and produce acids, right? Those acids then can fall and be deposited, right? It might be acid rain or acid fog or acid snow. And so we can just call it acid deposition. But anyway, so that is that and this cause. And again, acid deposition consists of rain, snow, dust, or gas with a pH lower than 5.6. So again, it's formed, it blows in the air, it reacts, and then, it falls down wherever it does. And why is this a regional problem? Well, if we take a look right here, so we can see now the red dot, one second, make sure I have this here, right? The red dot are the major coal burning and industrial plants. And if you can see, maybe like it's a little bit bigger here. Okay, we can see that around these areas, the pH is much lower. All right. Now, also notice this, it isn't a perfect circle around this plant or these coal burning power plants, right? Industrial plants. In other words, what's going on? Well, if you know that generally speaking, right, the jet stream and everything else, right, so the winds generally and the weather's flowing from the west to the east. So notice that often when you have the plants, the lower the pH, right, which means it's more acidic, is to the east of it, right, because of the weather. And so it's a regional problem. It's not just that coal burning power plant does not just affect that small little area. It can affect a region with it. Okay. All right, so you can take a quick look at that map. All right, question. It says, when soil, number 14, when soil becomes too acidic, especially below a pH 5.1, metals like lead, mercury, zinc, copper, cadmium, chromium are leached from the soil, pulled to deeper levels, and even released into the water supply. How does this affect aquatic systems and human health? Well, you can imagine, right? So if we take a look at this graphic here. Second. One second here. All right. To be very careful with as I'm doing this, making sure that it's actually projecting what I think is on the page. But anyway, here we go. So here's the deal, right? So when we have it, when we've acid rain, snow, whatever, right? Now, clearly this can damage the bark and leaves of trees, reduce photosynthesis, like monuments, right? They can start to erode, and obviously just affecting the trees and the leaves can affect all kinds of, cause all kinds of problems in the area. But another big problem, right? I mean, it can weaken the trees and make them more susceptible to other problems. But as this water that's very acidic moves through the soil, if it has a very low pH, it is more likely to bring with it some of these metals like lead and so forth, right? And so like release of toxic metal ions, right? Which then can be brought down, not only be damaging the roots, but also down to the groundwater and feed the lakes and everything else. This groundwater might be something that we pull up in a well and drink. And again, so it can be very common. In other words, if we find in a lake high levels of metals, these heavy metals, it might be a sign of acid rain in the area that is leaching these metals out. All right, so there are so many reasons why we want to stop not only just acid rain, but we have to remember, like, what is the cause of this acid rain? And so often it goes back to the burning of fossil fuels. And so if we, or when we, and if we get off of these fossil fuels, not only then, as we develop alternatives, not only are we not producing carbon dioxide into the atmosphere and the particulates, but also we're really addressing an acid rain problem too that can lead to metal in our water and all kinds of problems. So many reasons why it's best for us to make sure that we're developing our renewable energy resources. All right, so 15, why is controlling acid deposition politically difficult? Well, because, I mean, for so many reasons, as you can imagine. If you imagine, West Virginia, and again, like I've said many times, we owe so much thanks to coal miners from the standpoint of doing the hard work, keeping, the coal that was burned to make electricity, to keep the lights on, not only at your house, but the hospitals and all that kind of stuff, right? But all the other problems associated with it, we need to have been and to develop renewables, right? And we really should be phasing out the coal. But here's the problem, right? You could imagine in West Virginia, as one example, if someone is running to lead that state, if it's a state governor or whatever, and if their platform is, hey, I want to stop using coal, it's, good luck getting elected when you have so many people working in that industry. And so, I think just generally speaking, anytime someone's job potentially is at stake, there's going to be some issues for sure. So anyway, and also if we take a look at this map, right, we can see that, acid rain, acid deposition, once it's, these emissions go into the air, they cover large areas. They don't just affect your local place. And so some of this is about being good neighbors, right? In other words, if you are a state that is producing a lot of emissions, but your emissions go into another state, that other state really can't come over and make policy for the other state, if you know what I mean, right? So when we have states just kind of looking at their own self-interest and it's affecting their neighbor state, in this case, maybe acid deposition from the burning of fossil fuels, well, the states that are being most affected have limited ability to try to do anything to the other states to make them to try to not burn so much stuff. So that would be some of the reasons why it's politically difficult to control. All right, 16, what is the Clean Air Act and how is it helped reduce outdoor air pollution in the United States? And again, to answer this, I want to remind you that there was sort of like an awakening, we'll say, of wanting to learn more about the environment, to want to protect it. In the 60s, and a lot of people came out and protested, said, like, we don't like the direction of the amount of pollution of what we're seeing. And so because of that, Richard Nixon, who was president at the time, right, formed the EPA, which is the Environmental Protection Agency, and things like the Clean Water Act and Clean Air Act that came from that. And so, again, I am so thankful for the people that did all that hard work right back then, who protested, who really kind of stood up for us, the generations that would come after them, and said, we want better. We don't want our air to be polluted anymore the way it has. And so with the Clean Air Act, let me bring this up here too, see it right? So it's legislation that's a very powerful one, right? That has greatly reduced, carbon monoxide, nitrogen oxide, sulfur dioxide, suspended particulate matter. It limits, right, what can be produced, or I should say released and produced by certain industries. When we have a refinery, for gasoline, there are going to be emissions. It's just the way it is. And so they will set emission limits, how much sulfur dioxide and other things that will be allowed to be released into the air. And although, yes, you might say, well, wait, you're still releasing it. Yes, there are things you can do to try to reduce that, which I'll talk about in just a moment. But again, it's so much better than nothing, than when they could just release whatever they wanted into the air. So again, the Clean Air Act is going to limit these things that can be released, put a limit, put an amount that is allowable to be released by anybody. All right, question 17. Explain how wet scrubbers work to reduce sulfur dioxide and particulate emissions from coal burning power in industrial plants. All right, so remember, as we're burning stuff like coal that has sulfur in them, at these temperatures, when it's burning, the sulfur reacts with oxygen to make sulfur dioxide, wants to go into the air and react with water in the atmosphere to make sulfuric acid. So this is what a wet scrubber does. So in other words, here is the dirty gas, right? From what's being burned. Now, instead of that going just straight out into the atmosphere, it then goes up into the wet scrubber. Now, it's funny to think what you have is this water that's being shot into the air, right? A mist of it is being shot, almost like a hose, but a fine mist, right? Why? Well, it'll actually wash out a lot of it, up to 98% of the sulfur dioxide in particulate matter. So as it's rising up, the water vapor hits it and it dissolves in the water, and now it flows down here. Now notice the water down here, is it going to be polluted? Absolutely, right? Will it have sulfuric acid in it? Absolutely. But what we did is we now prevented it from going into the air, and now we can do some things with this, or try to do some things, right? Try to neutralize it so that it's not acidic anymore, right? So this is one thing that can remove up to 98% of the sulfur dioxide. And remember, why were we concerned? Because we don't want that to get out and form acid rain outside. Right, so this is what a wet scrubber is. Now, wet, that gives you a hint. It's using water. All right, and finally, question 18. Explain how electrostatic precipitators work to reduce sulfur dioxide and particulate emissions from coal burning in industrial plants. Now, I'll say it like this. Have you ever had the experience, let's say a balloon, and you kind of rub it against your hair, right? And then you can stick it to a wall or something? You know what I mean? Because it has that charge on it, right? Well, the same sort of concepts works. The electrical charge can stick to things, right? So you can have this electrostatic precipitator. So let me share this with you. All right. So imagine here's the dirty gas, and again, instead of going out into the atmosphere, it goes through the electrostatic precipitator. What we have here is this electrode that has a charge, right? And all the particulate matter is floating up, and right, it sticks to it. Up to 99% of the particulate matter gets sucked in and now sticks to this electrode, right? We could then collect that, and then we've just pulled it out of the air so that it's not going out into the atmosphere. All right, and so you can imagine when we have both the electrostatic precipitator and the wet scrubber working, you can really reduce the amount of pollutants that are going out into the air. All right, so that's that. Those are the answers for these review questions.